The U.S. military spent 22 years and billions of dollars on robot dogs. China spent 2. And theirs are already armed with rocket launchers heading to the front line. The Americans are still doing security guard shifts at the base. This footage is real. It's from the People's Army's brand new promotional video winning released this year. And what you're seeing mounted on these dogs isn't a toy rifle. Dual 93mm rocket launchers, light machine guns, independent rotating gun mounts, one dog, half a squad's firepower, on 4 legs. So why now? Boston Dynamics had a prototype in 2005. DARPA was funding this in 2004. The technology has existed for 20 years. So what changed? And why is it China, not the United States, that's putting armed combat robot dogs on the actual battlefield first? The answer isn't what most people think. It's not about the robot. It's about 3 problems that nobody talks about, and how one country quietly solved all 3 while the other is still stuck on step 1. Because here's what the headlines miss: building the dog is actually the easy part. The real challenge is everything that comes after. How does a robot dog fight alongside human soldiers in a chaotic urban battle without shooting its own teammates? Where exactly do you put the operator in a 6-seat infantry vehicle that's already full? And when a company commander used to managing 4 weapons, now has to manage 14, including drones, loitering munitions, and robot dogs simultaneously, how does that even work? By the time we're done, you'll understand why the robot dog might be the most disruptive thing to hit infantry tactics since the machine gun, and why the gap between China and everyone else on this is wider than it looks. Let's start with what this thing can actually do, because the numbers are genuinely absurd. A conventional infantry squad's entire direct fire arsenal: rocket launcher, rifles, machine gun, designated marksman rifle. That's it. Past robot dogs, even the ones people got excited about, were civilian machines with a Type 95 or Type 191 rifle zip tied on top. Fixed in place. The only way to aim was to rotate the dog's entire body like some kind of 4-legged pivot cannon from a 19th century warship. What's in winning is a different animal entirely. Dual 93mm rocket launchers. Type 201 light machine gun. Rifle variants with fully independent elevation, capable rotating gun mounts. One dog replacing half a squad isn't marketing language anymore. It's a functional reality. But the platform's ceiling goes far beyond what's currently mounted on it. Here's why. A soldier weighing 70 kg should carry no more than 21 kg in combat. Hard limit is 31.5 kg even on a march. The Americans pushed past all of that. Their 2016 data showed an average combat load of 117 pounds, 53 kg, and they paid for it in musculoskeletal injuries and combat effectiveness. But even at 53 kg, how much of that is actually weapons? Almost none of it. Uniform, boots, gloves, helmet, body armor, ceramic plates, carrying rig, night vision, first aid kit, water bottle, radio, 3 meals, personal hygiene supplies. All of that is dead weight from a firepower perspective. The 25 kg on the dog's back is pure combat payload. Nothing else. And 25 kg isn't even close to what the dog can actually carry. Extreme load testing shows no less than 150 kg capacity. At 70 kg, it was still walking briskly, which means if you started purpose-building weapons for this platform, instead of just mounting human spec gear, ACOG scopes, tactical flashlights, foregrips, stocks, pistol grips, all of it completely useless to a machine, you could go much heavier. Strip a weapon down to what a robot dog actually needs: barrel, automatic mechanism, feed port, electrical interface. That's it. 4 components. Orange Cat did the math on mounting a Russian GS H-31 aircraft autocannon, the 30mm gun off a Su-27 or MiG-29. Bear cannon, 46 kg, world's lightest 30mm cannon. The dog already has electro-optical fire control built in, so you don't need the rotation system's single-axis elevation only. Electric drive, 34 kg, recoil buffer 3 kg, peripherals 12.9 kg, total system around 59 kg. Still leaves 11 kg for ammunition, though the catch is aviation rounds at 800 plus grams. Each means 20 rounds is already 17 kg and gone in a single second of fire. You'd need purpose-built lighter ammunition to make it practical. But the point stands. This platform's weight utilization is so efficient that weapons deserve to be designed around it from scratch, not adapted from human use. The Tianlong Q25 platform was built with exactly this in mind. Flat top surface, multiple standardized screw holes, rail mounting points pre-installed, a Picatinny rail system for dogs, 120 mean thermobaric shells, Red Arrow 12, Red Arrow 73 anti-tank missiles, all theoretically mountable. The platform potential is essentially unlimited. So why did it take until now for combat robot dogs to actually appear at scale? 3 problems. All of them brutal. None of them about the robot itself. Problem 1. Human-machine coordination. Modern warfare at the squad level is a tightly choreographed system. Take a squad clearing a building. Nobody charges blindly, that's movies. Real infantry establishes division of labor immediately. Machine gunner suppresses enemy fire from windows. Designated marksman picks off exposed targets. Rocket launchers pound firing ports. Grenadier handles breach. Everyone's timing is synchronized. That's why in Slavic region urban warfare, they'll pour rocket fire into a building until it literally collapses before sending a single soldier in, because coordinated firepower saves lives. That squad system has at least 5 distinct roles. The coordination demands are extreme. You cannot have the rocket launcher shooter expose himself right when the machine gunner is reloading. Timing between roles is everything. Now add a robot dog, mount a machine gun on it, designate it as machine gunner. Immediately it needs answers to questions that seem simple but aren't. Which windows to suppress? At what rhythm? Single shots or bursts? What happens when a silhouette appears in a side room, mid-suppression teammate flanking or new enemy? If it's an enemy, do you break suppression to engage? You cannot break suppression when the rocket launcher shooter is already half exposed. If it's a teammate, how does the dog even know? Traditionally, this is handled by radio. I'm entering building 3. Don't shoot. AI image recognition sounds like an obvious solution, but the prerequisite is a clear image. Battlefield smoke, explosions, variable lighting, fire shadows, none of that gives you clean frames to work with. AI identification of blurry battlefield imagery is one of the hardest unsolved problems in the field right now. Loitering munition drones with much simpler identification requirements. Does that vehicle look like a tank? Have still accidentally killed civilians in Iraq and Afghanistan. The grassroots combat environment is exponentially more complex. A military will accept equipment that performs slightly worse. It will not accept equipment that is unreliable. Those are very different standards. Throwing a large language model at this problem and hoping generalization covers the gaps is fantasy. In 2026, the U.S. military tried exactly that with Maven for target recognition workflows. Everyone saw how that went. For now, robot dog control needs traditional swarm intelligence optimization algorithms at the base layer, with human judgment layered on top, not the other way around. Problem 2. Where do you put the people? Operators can't sit hundreds of kilometers away like drone pilots, not for squad-level robot dogs. Control has to be at the front line. So the operator walks with the squad, which means you need additional personnel in an organizational structure where space is already at an absolute premium. A standard IFV has 6 seats. If you're adding a robot dog operator, are they hanging off the outside? If you don't add people, you have to cut someone. The machine gunner, a rifleman, the rocket launcher operator. Every one of those cuts has tactical consequences, and the dog itself has a movement problem. An IFV moves at tens of kilometers per hour. The dog can't keep pace. Dedicated transport vehicle, space inside the IFV, strapped to the exterior. If you need a dedicated transport vehicle, where does it slot in the organization, company, or battalion level? Who drives it? Who maintains it? When the dog breaks down, and it will break down, you need specialized repair units, just like armored vehicles need field mechanics. Where does field charging happen? Can the IFV's power supply even handle fast charging multiple robot dog batteries simultaneously? Who manages the swapped out packs? Every single one of these questions needs a concrete answer squeezed from an existing organizational structure that has zero slack. Operator placement, transport, maintenance, repair, charging, battery management. That's an entire new support chain that has to plug into the grassroots system without touching the existing structure's bones. You can't replace thousands of IFVs across the entire military just to accommodate a robot dog. Problem 3. Tactics and Doctrine 1 robot dog carries half a squad's firepower. 2 dogs, and you're managing firepower density that historically required a higher command echelon. With algorithms not yet mature enough for autonomous decision-making, a soldier can't mentally control the rocket launcher dog with one hemisphere and the machine gun dog with the other simultaneously. That's not operationally viable. But endlessly expanding the operator headcount isn't either. The only workable answer is that every soldier at the squad level needs sufficient operational knowledge to handle the robot dog when required. And today's combat dog isn't a one-rifle machine anymore. It carries rocket launchers, machine guns, anti-tank missiles, rifles, all simultaneously. Every operator needs to understand the tactical application of every weapon type, correct machine gun positioning, appropriate fire rhythm, right engagement distance for anti-tank missiles against different target types, and basic field diagnostics when the dog malfunctions. In the old days, a soldier managed one rifle. Now everything on the dog's back is their responsibility. Once the soldiers are trained, the commander's headache begins. The soldier's challenge is knowing everything. The company commander's challenge is managing everything simultaneously. Previously 4 weapons, infantry, vehicles, heavy machine guns, mortars. Now combined arms has filtered all the way down to company and squad level. Tanks, IFVs, infantry, scouts, machine guns, mortars, grenade launchers, snipers, drones, robot dogs, loitering munitions, manned and unmanned coordination, command authority division, fault and communication loss protocols. None of it can be explained in a briefing. It requires constant life force exercise, improved operational doctrine, scientific evaluation standards, and repeated testing cycles until mature practice solidifies into standard procedures and training subjects. Here's what's actually interesting. Orange Cat's point isn't that these problems are showstoppers. Most of them are what you'd call happy headaches, because they only need to be solved by us. Other countries aren't working on this not because they don't want to. They just haven't gotten there yet. The Americans' few hundred Vision 60 units are still guarding bases. 0 frontline deployment. Ukraine's robot dogs are being used to trip landmines literally as expendable mine-clearing tools. As for certain other parties, standing upright without falling over is currently considered a success. So what's the actual gap? One threshold: algorithm deployment. The sim-to-real problem. In simulation environments like Isaac Sim or MojoCo, robot dogs run, jump, navigate obstacles with beautiful smooth motion. Transfer those algorithms to real hardware, and the moment terrain gets slightly irregular, the dog starts twitching, tripping, and spinning in place. Most robotics companies are still stuck here. The solution is simple in concept and brutally hard to replicate: massive real-world scenario data. Domestic markets and industrial inspection, security patrol, and emergency rescue have provided enormous ready-made testing grounds that no other country has at comparable scale. Terrains and scenarios the dog has never encountered reveal failure modes that simulation never shows. The flashy advanced algorithms from research labs are often not the most deployable solution. The most stable, most mature, actually fieldable dog is what the military needs, and getting there requires millions of real-world hours that can't be simulated. On production and cost, the gap is just as stark. One domestic company sold 33,000 quadruped robots between 2023 and 2025, capturing 60% of global market share. Advanced robot dogs have dropped to 5,000 or 6,000 yuan per unit. Ghost Robotics Vision's 6010 kg payload starts at 150,000 USD. Unitree's industrial B2 25 kg payload, 77,000 USD. 2.5 times the payload at exactly half the price. Tens of thousands of units annually on one side, a few hundred on the other. The supply chain math speaks for itself. Core components self-produced, standard parts and machined components fed directly to automotive, UAV, and consumer electronics supply chains cultivated over years. Costs collapse accordingly. By 2026, the first comprehensive robot industry chain standards have started rolling out domestically. Overseas, they haven't even unified basic standards yet. Military-spec modularized robot dogs aren't even a near-term conversation for them, let alone the organizational structure, tactics, and doctrine questions that come after. Making the dog is easy. Reforming the squad around it is hard. Add a robot dog to the organizational chart, and the tactics, logistics, support chain, and command structure all have to do somersaults simultaneously. That's not a criticism, that's the work. And it's work that right now only one military in the world is actually doing at scale. The Americans are still debating the XM7. We're already bringing dogs ready to hit the beaches. What weapons do you think should be added to the robot dog at the squad level? Drop it in the comments. Like, subscribe, see you next episode.